In this video, I shall present the solutions for the third part of test 12. Exercise 1. The ABC triangle in the figure below has the measure of angle BAC equals to 90 degrees. AB equals 30 centimeters and AC equals 40 centimeters. Let AQ perpendicular on BC, Q belonging to the BC segment, and M and P are the middle of BC, CA, and AB sides respectively. Point A. Prove that the triangles APN and QPN are congruent. P is the middle of AB segment, results that AP is equal to half of AB. We mark this statement as 1. The segment QP is the median in the right triangle AQB, so QP is equal to half of AB. We mark this statement as 2. From statements 1 and 2, we have that the segment AP is congruent to the segment QP. N is the middle of AC segment, so AN is half of AC. We mark this statement as 3. Segment QN is median in the right triangle AQC, so QN is half of AC. We mark this statement as 4. From statements 3 and 4, we have that segment QN is congruent to segment AN. We mark this statement as 6. PN is common side, so from 5, 6, and 7 statements we have with the criterion side that APN triangle is congruent to PQN triangle. Point B. Calculate the parameter of the quadrilateral MNPQ. The segment MN is mid-segment in the triangle ABC, so MN is half of AB. From this we have that MN is equal to 1/2 of 30, which is equal to 15. From the right triangle ABC, we have with Pythagoras' theorem that BC squared is equal to AB squared plus AC squared. So BC squared is equal to 30 squared plus 40 squared, which is equal to 900 plus 1600, which is equal to 2500. So BC is equal to square root of 2500, which is equal to 50. PN is mid-segment in triangle ABC, so PN is half of BC, which is equal to half of 50, which is equal to 25. We calculate the surface area of the ABC triangle using Heron's formula. So the semi-parameter of the triangle ABC is equal to AB plus AC plus BC, everything over 2, which is equal to 60. The surface area of the ABC triangle is equal to square root of P times P minus AB times P minus AC times P minus BC, which is, by doing the substitutions and calculations, is equal to 600. We calculate the surface area of ABC triangle using the classical formula of base times height, everything divided by 2, in order to determine the height of the triangle. So we have calculated the surface area of ABC by Heron's formula, so we can now calculate the height AQ, which is equal to 2 times surface area of ABC triangle, everything divided by BC, which is equal to 24. From the right triangle AQB, we have with Pythagoras theorem that AB squared is equal to AQ squared plus BQ squared. So BQ squared is equal to AB squared minus AQ squared. So BQ squared is equal to 900 minus 576, which is equal to 324. So BQ is equal to square root of 324, which is equal to 18. M is the middle of BC segment, and from this we have that BM is equal to MC, which is equal to half of BC, which is equal to 25. BM is equal to BQ plus QM, so QM is equal to BM minus BQ, which is equal to 25 minus 18, which is equal to 7. So the parameter of the MNPQ quadrilateral is equal to MN plus PN plus PQ plus QM, which is equal to 15 plus 15 plus 25 plus 7, which is equal to 62 centimeters. Point C. Prove that the points M, N, A, P, and Q are located on a circle. Let O be the middle of segment PN. Results that OP segment and ON segment are congruent. So OP is equal to ON, which is equal to PN divided by 2, which is equal to 25 divided by 2, which is equal to 12.5. Segment PN is mid-segment in ABC triangle. So AR segment is congruent to RQ segment. So AR is equal to RQ, which is equal to AQ divided by 2, which is equal to 12. From the right triangle ARP, we have with Pythagoras theorem that AP squared is equal to AR squared plus PR squared. So PR squared is equal to AP squared minus AR squared, which is equal to 15 squared minus 12 squared, which is equal to 81. So PR is equal to the square root of 81, which is equal to 9. PO is equal to PR plus OR, so OR is equal to PO minus PR, which is equal to 3.5. From the right triangle ARO, we have with Pythagoras theorem that AO squared is equal to AR squared plus RO squared. So AO squared is equal to 12 squared plus 3.5 squared, which is equal to 144 plus 12.25, which is equal to 156.25. From this we have that AO is equal to square root of 156.25, which is equal to 12.5. From the right triangle QRO, we have with Pythagoras theorem that OQ squared is equal to OR squared plus RQ squared. So OQ is equal to 3.5 squared plus 12 squared, which is equal to 12.25 plus 144, which is equal to 156.25. So OQ is equal to square root of 156.25, which is equal to 12.5. MN is mid-segment in ABC triangle, so MN is parallel to AB. So the measure of the BAC angle is equal to the measure of MNC angle, which is equal to 90 degrees. The measure of MNA angle is equal to 180 minus the measure of MNC angle, which is equal to 180 minus 90, which is equal to 90 degrees. From the right triangle ANM, we have with Pythagoras theorem that AM squared is equal to AN squared plus NM squared. So am squared is equal to 20 to the power of 2 plus 15 to the power of 2, which is equal to 400 plus 225, which is equal to 625. So am is equal to square root of 625, which is equal to 25. Pn is mid-segment in ABC triangle, and Pn intersected with AM is point O. From these two statements results that AO is equal to OM, which is equal to half of AM, which is equal to 25 divided by 2, which is equal to 12.5. OM is equal to ON, which is equal to OA, which is equal to OP, which is equal to OQ, which is equal to 12.5, and this represents the radius of the circle circumscribed to the triangle. So M, N, A, P, and Q are equally distant from point O. From this results that M, N, A, P, and Q belong to a circle. Problem number 2. In the figure below it is represented a regular triangular pyramid ABCD with the base AB equals 3 meter, apothema DM 1 meter, M belongs to BC, and height DO. Let V belonging to DO, D belongs to VO, so that VD is equal to 9 DO. Point A. Prove that DO is equal to 0.5 meters. B. Determine the length of the VO segment in meters. C. Calculate the tangent of the angle formed by the line DA with the plane ABC. Point A. ABC triangle is equilateral, so AM is equal to 5 to the side multiplied by the square root of 3, everything divided by 2, which is equal to 3 square root of 3, everything divided by 2. O is center of gravity, so for ABC triangle, we have that OM is 1/3 of AM. OM is equal to 1/3 of 3 square root of 3, everything divided by 2, which is equal to square root of 3 divided by 2. From the right triangle DOM results with the Pythagoras theorem that DM squared is equal to DO squared plus OM squared. So DO squared is equal to DM squared minus OM squared. So DO squared is equal to 1 squared minus square root of 3 divided by 2 squared, which is equal to 1 minus 3 over 4, which is equal to 1 over 4. So DO is equal to square root of 1 over 4, which is equal to 1 over 2, which is equal to 0.5 meters. Point B. VD is equal to 9 DO, which is equal to 9 times 0.5, which is equal to 4.5 meters. VO is equal to VD plus DO, which is equal to 9 DO plus DO, which is equal to 10 DO, which is equal to 10 times 0.5, which is equal to 5 meters. Point C. AO is equal to 2/3 of AM, which is equal to 2 over 3 times 3 square root of 3 over 2, which is equal to square root of 3. From the right triangle AOD, we have with Pythagoras theorem that AD squared is equal to DO squared plus AO squared. So AD squared is equal to 0.5 squared plus square root of 3 squared, which is equal to 0.25 plus 3, which is equal to 3.25. So AD is equal to square root of 3.25, which is approximately equal to 1.8. The tangent of angle between the DA line and plane ABC is equal to the tangent between the lines DA and AM, which is equal to the tangent of angle DAO, which is equal to DO over AO, which is equal to 0.5 over square root of 3, which is, we amplify this by fraction by 2, which is equal to 1 over 2 square root of 3. We amplify by a square root of 3, which is equal to square root of 3 over 6. This was the third part of test 12. Thank you for your attention. Goodbye.